Hi everyone, welcome to another session of the HPL files. Today we will be solving problems about measurements, motion, and forces. This will include speed, velocity, acceleration, graphs of equations, density, adding forces, and circular motion. Let's begin with the multiple choice questions. Here we have the diagrams showing the readings on a measuring cylinder before and after a small metal cube is added. How many more metal cubes can be added to the cylinder without causing the water to overflow? Do not include the cube already in the cylinder. Well, looking at the diagram, we can identify that the volume of one metal cube is equal to 2 cubic centimeters, which means we can only add 2 more metal cubes without causing the water to overflow. That means the answer is letter B. Next, which person is experiencing an acceleration? Let's look at the choices one by one. If you look at letter D, a skydiver falling at constant speed towards the Earth, this speed is actually what we call as the terminal speed. And remember, when an object achieves terminal speed, the weight is equal to the drag, meaning the net force is zero. If the net force is zero, the acceleration is also zero. Looking at letter C, a shopper in a large store ascending an escalator at a uniform rate. So at a uniform rate means at a constant velocity. Constant velocity means zero acceleration. In letter B, we have a passenger in a train that is stationary in a railway station. Being stationary means that all the net force, the net force is zero. So that means the acceleration is also zero. That leaves us letter A, wherein a driver of a car that is braking to stop at traffic lights. When the driver hits or presses on the brakes, therefore, the magnitude of the velocity of the car changes. So if there's a change in the velocity, therefore, there is acceleration. Next question. A car travels at various speeds during a short journey. So we have here the table for the distances traveled and the times taken. During which two stages is the car traveling at the same average speed? So remember, when we compute average speed, we get the total distance over the total time. Here, those data were already given to us. All we have to do is determine the average speed for each stage. For letter P, it will be 0.9 kilometer per minute. For Q, it will be 1.8, R 0.68, and then for S, 0.9. That means the answer will be stages P and S, which is letter B. Next, we have these two blocks of metal X and Y hanging on this Newton scales or Newton meter. Now, the question is, what does the diagram show about X and Y? Notice that if you look at the diagram, we can see that X and Y are of different volumes, but the same force registers on the Newton meter. This force is actually pertaining to their weight. Among the choices, only letters B, C, and D are mentioning the same weight. But if you look at letters C and D, they mentioned the same volume, which is not the case. Looking at letter B, it says that they have the same mass, which is true. Why? Because weight is equal to mass times gravity. Both X and Y experiences the same gravity, and since their weights are the same, that means their masses are the same. And obviously, their volumes are different. So that means the answer is letter B. Next, a 1 kilogram sample of aluminum is stored in a laboratory. In a different laboratory in the same town, there is a 1 kilogram sample of iron. Which quantity must these two samples always have in common? So we were given with the mass, and the mass of the two samples are equal. Okay? So that means their weight will be equal because again, they will be affected by the same acceleration due to gravity. Next, a measuring cylinder has a mass of 120 grams when empty. When it contains 50 centimeter cube of a liquid, the total mass of the measuring cylinder and the liquid is 160 grams. What is the density of the liquid? So to solve for density, we need the mass and the volume. The volume is given here, 50 cubic centimeters of a liquid. For the mass of the liquid, we just have to subtract these two masses. The mass of the cylinder when it's empty and subtract that from the mass of the cylinder plus the liquid. So 160 minus 120 gives us 40 grams for the mass, and then 40 divided by this volume gives us the density. That means the answer is letter A. Next, a car moves along a level road. The diagram shows all the horizontal forces acting on the car. Which statement is correct? Before we go on to the choices, let's look at the forces first. Notice that there are two forces acting to the left. That means we can combine these two forces, and it will result to 1,300 newtons. Getting the net force acting on the car, we have the following. 2,000 is directed to the right, so it's positive. On the other hand, the 1,300 newtons is directed to the left, so we make it negative. The net force will be 700 newtons. The net force is directed to the right, which is the forward direction of the car, which means the acceleration is also directed to the right. Since that is the case, this will result to the car speeding up. Okay, that means the answer is letter B. Next, a student measures the length of a rod XY by holding it next to a meter rule. The student writes down the length as 94.8 centimeters. Which statement is correct? So looking at the choices, first letter A, the value is correct. Definitely, it's not correct. Why? Because having a measurement of 94.8 centimeters means that the object that you are measuring was initially, or one end of the object that you're measuring is placed on the 0 centimeter, and then the other end should be at the 94.8 centimeter mark, which is not the case in this scenario. That means letter A is not correct. Letter B, the value is incorrect because it should be 95.2 centimeters. Now, looking at the scale, 95.2 is actually around this point, which is again incorrect. Letter C, the value is incorrect because it should be in millimeters. Now, notice that the 94, 95, 96 are basically in centimeters, which is correct. If you want to express this one in millimeters, there should be 940, 950, and so on. Now, looking at letter D, the value is incorrect because the student should subtract the reading for end Y from the reading for end X, which is what should have been done to get the correct measurement. Notice that the first end of the object is located at the 94.8 centimeter mark. And then the other end will be around 99.7, around this point. So to get the measurement of this object, you must subtract those two measurements. That means the answer is letter D. Next, a heavy metal ball falls vertically downwards through air past 4 equally spaced levels, J, K, L, and M. The times taken to fall from one level to the next are measured. Where is the speed of the ball greatest and which time is shortest? Notice that when the ball, or as the ball falls down, its speed increases. Why? Because the velocity is directed down and the acceleration is also directed down. Since we are dealing with equally spaced levels, then therefore, the greater the speed, the shorter time it takes for the metal ball to travel those distances, which means the greatest speed will be found at the bottommost part of the distances considered. So that means that will be between L and M. Greatest speed will be around this level. And again, the greater the speed is, the shorter the time, which means the shortest time measured will be also between these levels. So the answer will be letter D, between levels L and M. Next, a workman measures as accurately as possible the length and internal diameter of a straight copper pipe. The length is approximately 600 centimeters and the internal diameter is approximately 2 centimeters. What is the best combination of instruments for the workman to use? Now remember, when we are dealing with small measurements and external and internal diameters, the best instrument to use will be a vernier caliper. Among the choices, only letters C and D indicated the vernier caliper for the internal diameter measurement. Now, notice that the length is approximately 600 centimeters. A ruler only measures a maximum of 30 centimeters. So that means the best option for the tools to use here will be the vernier caliper for the internal diameter and the measuring tape for the length. Next, the graph shows how the speed of a car traveling in a straight line changes with time. Which section shows the largest acceleration? Now remember that the gradient for this graph represents acceleration. So the steeper the graph is, the greater the acceleration will be. Looking at the choices, the part where the steepest graph is located will be at letter A. Next, an object falls from rest through the air and the air resistance on it increases. The object reaches terminal velocity. Which quantity decreases until its terminal velocity is reached? Take note that as an object falls down, its weight, which is represented by the black arrow, stays the same, while the drag or the air resistance it experiences will increase until such time that the weight is equal to the drag, which is the condition for terminal velocity. When this is the case, that means the net force is 0, which means as the object falls down, the net force decreases. If the net force decreases, that means the acceleration or the net acceleration decreases. So for this question, the answer will be letter A. Okay, we have here on the next question, a man pushes a heavy box along the ground. A force acts between the man's hands and the box. Another force acts between the man's feet and the floor. In which direction do these forces act on the man? So in this question, we are looking at the forces that are acting on the man. Now, if you look at the feet of the man, his feet are actually exerting a force on the ground that is directed to the left. So that means the force exerted on the man's feet will be directed to the right. Here, the person or the man is pushing the box to the right. So the force acting on the man's hands will be to the left. Okay, so knowing that, this tells us that the answer will be letter B. The force on man's hands will be to the left, force on man's feet to the right. Next, in which situation is the resultant force on the body equal to 0? Looking at the choices, we have the following. First, okay, we have in letter A, a car turning a corner at constant speed. Now, when an object turns on a curve or traces a circular path, that means there is a centripetal force. And centripetal force is a resultant force. Next, a rock falling freely from the moon. A rock that falls freely on the moon means that it's still affected by the acceleration due to gravity. That means there is a resultant force acting on it. On letter D, we have an aircraft accelerating. Okay, if an object accelerates, that means there's a net force or resultant force acting on it. So for this question, the answer will be letter C. Why? Because it says here that the train is traveling at constant speed in a straight line. Constant speed in a straight line means uniform velocity or constant velocity. Constant velocity means zero acceleration. And zero acceleration pertains to zero net force. Next. A satellite is orbiting the Earth. What is the direction of the force on the satellite causing this circular motion? So again, this situation is an example of a centripetal motion. So if this is the case, that means there is a centripetal force acting towards the center of the circular path, which means the answer will be letter D, towards the center of the Earth. By the way, for this example, the one that provides the centripetal force is the gravitational force exerted by the Earth on the moon. Next, 4 objects are situated in places with different gravitational field strengths. Which object has the greatest weight? Now, gravitational field strength is the general term for the acceleration due to gravity. So here, to find the weight, we just have to multiply the mass and the gravitational field strength, and then compare the results. So for letter A, we have a weight of 31.2 newtons. Letter B is 33.25. Letter C is 40.8. And letter D is 40.5. So that means the answer is letter C. Next, which is the value of a vector quantity? So again, quantities in physics can be classified as a scalar, which requires magnitude only, and vector, which requires both magnitude and direction. The magnitude refers to the measurement. So among the choices, only letter C indicates a direction, which is 20 meters per second. The magnitude, east is the direction. So this is a value for a vector quantity, specifically velocity. Okay, so in this question, we have a spring that obeys Hooke's law, which graph is obtained by plotting the extension of the spring against the load applied. Okay, so remember that the equation for Hooke's law is F is equal to Kx, where K is the spring constant. F refers to the force or the load, and then X is the extension. Notice that this equation follows the equation for a direct proportionality, which has a general formula of y is equal to kx. Now, for a direct proportionality, its graph should be a straight line with a positive slope, in this case. And the straight line graph should pass through the origin. So among the choices, letter A shows that kind of graph. Okay, let's now go on to the short answer and extended response questions. For the first question, we have a figure that shows a distance time graph for a moving object. Describe the speed of the object between points A, B. So notice that the graph or the distance time graph at points A, B is a curved graph. And remember that for a distance versus time graph, the gradient or the slope represents the speed. Since the gradient becomes, or the gradient decreases, because as you can see, as time passes by, the graph becomes a bit more horizontal. So again, gradient decreases. If the gradient decreases, that means the speed decreases as well. Now, between points B, C, notice that the graph is relatively straight. A straight graph means the gradient is constant. If the gradient is constant, that means the speed is constant. Next. Letter B, state whether the acceleration of the object is 0, negative, or positive as shown on the graph between points A, B. Now, again, here between points A, B, we have established that the speed decreases. If the speed decreases, that means the object slows down. The object can only slow down if the velocity and acceleration are in opposite directions. That means if the object's velocity is to the right, the acceleration is to the left. So if we consider the velocity's direction to be positive, that means the acceleration should be negative. Next, between points B, C, the speed is constant. If the speed is constant, and assuming that the object is traveling in a straight line path, that means the velocity is constant. If the velocity is constant, that pertains to a situation wherein the acceleration is 0. Okay. Next, letter C, calculate the average speed of the object during the 40 seconds. So average speed can be determined by dividing the total distance by the total time. The total distance and the total time can be obtained from the graph. Total distance is 50 meters. Total time is 40 seconds, giving us an average speed of 1.25 meters per second. Okay. On the next problem, we have a figure that shows a lorry accelerating in a straight line along a horizontal road. The driving force on the lorry in the forward direction is D, and the total backward force on the lorry is B. State and explain whether D or B is the larger force. Now, take note that the lorry is accelerating in the forward direction. This means that the force in the forward direction is greater than the force in the backward direction. If that is the case, that means the net force is in the forward direction. So this is basically consistent with the information given in the problem. This means that D, again, is larger than B. So again, using that explanation, we can say that the forward driving force is larger than the backward force. We can base it from the acceleration or based from the net force. By the way, the acceleration we're pertaining to is the net acceleration of the lorry. Next question, suggest one possible cause of the backward force B. Now, the most obvious answer for this one will be the drag force. Or in some cases, you might say the air resistance experienced by the lorry. Okay. Although we can also consider some frictional forces that are acting between the lorry and the ground, that can also be considered. Next part of the question, the weight of the lorry is 300,000 newtons. The gravitational field strength G is 10 Newton per kilogram. Calculate the mass of the lorry. To calculate the mass, we can simply make use of the formula for weight, which is weight is equal to mg. Solving for the mass, we have weight over g. Substituting the given values, we'll obtain a final value for the mass of 30,000 kilograms. Next, the resultant force on the lorry is 15,000 newtons. Calculate the acceleration of the lorry. So to solve this, we'll make use of Newton's second law, which is F is equal to ma, and solve for the acceleration. Substituting the given values, we have a final value of 0.5 meters per second squared for the acceleration. Okay, next, letter C. Later, the lorry turns a corner at constant speed. Explain why the lorry accelerates even though the speed is constant. Now remember, when the lorry turns a corner, even though the speed is constant, the direction of its velocity changes. So when there's a change in the velocity, that means there is an acceleration. Okay? And in fact, the acceleration or the centripetal acceleration, as well as the centripetal force, is actually directed to the center of that circular path or arc that the lorry was tracing. Okay? Next problem. A driving instructor gives a student a sudden order to stop the car in the shortest possible time. Figure 1.1 shows the speed time graph of the motion of the car from the moment the order was given. For the questions, we have the order to stop is given at time t is equal to 0 second. State the speed of the car at time is equal to 0 second. So to know that, let's go back to the given graph. At time is equal to 0 second, the speed is 18 meters per second. Next, suggest why the car continues to travel at this speed for 0.9 seconds. Now remember, when information is given to us to process, our brain will take a certain amount of time to decide what our body will do. And then sending out that instruction to the body, that will also take time. The time it takes for the mind to process the information given to us and for our body to finally react is actually pertaining to the reaction time. Since we have a certain reaction time, that means our body will take some time to respond to that information. And that is the reason why the car continued to travel for this speed for this amount of time. Because the student, or this is the time it took the student to react to the instruction of the driving instructor. Next, calculate the deceleration of the car between time is equal to 0.9 seconds and time is equal to 4.0 seconds. So to solve this, let's again go back to the graph. Notice that at 0.9 seconds, the initial speed will be 18 meters per second. And then at 4 seconds, final speed will be 0. And then the total time will be 4 seconds minus 0.9, which is basically 3.1 seconds. Now, using that information, let us compute the acceleration. Now, the acceleration is simply the change in velocity over time. Here, we're considering the magnitude of the velocities, which will be the speeds. So, substituting the given information, we have 0 minus 18 over 3.1. This gives us acceleration is equal to negative 5.8 meters per second squared. So the negative means that the acceleration is in the opposite direction of the velocity. Okay. Next, calculate the total distance traveled by the car from t is equal to 0 seconds. So looking at this graph, to calculate the total distance, we should find the area under the graph. Why? Because when we find the area under the graph, it's essentially multiplying speed to time, which gives distance. Now, the area under the graph can be divided into two. First one will be a rectangular area. Second one will be a triangular area. So we have the following solution. For the rectangular area, this length will be equivalent to 0.9 seconds. And then this width or height will be 18 meters per second. For the triangular area, of course, the area for a triangle is 1/2 base times height. So we have the factor 1/2. The base will be 4.0 minus 0.9, or simply 3.1. And then the height is, of course, 18. This gives us a total area of 44 meters. That means the total distance traveled by the car from time is equal to 0 is 44 meters. Okay, so that's it, guys. Thank you for learning with me today. By the way, kindly subscribe to my channel for more physics tutorial videos. See you on the next session of the HBL files.